Hello there. Let's use what we covered in class about parallel lines to prove something about angles created inside of them. So here I'm going to have two parallel lines, M and N, and actually let's denote that with a sketch here. Okay, so I got those arrows now to let me know that these two lines, M and N, are parallel to each other. And if I go to any point out there, the angles here, A, and this one down here, B, their sum is going to equal this angle over here, C, and that's what we want to prove. So, start this one off. Let's create a two-column proof and state the givens. Now, one of the big tricks on a lot of these problems is you can add in additional lines as you need, as long as those lines only do one thing. So I'm actually going to create a line that goes through this point out here. And I'm going to call it P. So P goes through that intersection point there for that angle. And I'm going to choose line P to be such that it is parallel to, I'll do the top one, line M. And I'm going to chalk this up as a given that it's going to be possible to create a parallel line to another through a point. Now, what we actually showed in one of the previous videos is that if M is parallel to N and M is parallel to P, then P must be parallel to N. But I'm getting ahead of myself a little bit. I actually just want to concentrate on these two lines, these purple ones here. Those are parallel lines, and you get something with the angles. So what do we get? This angle up here, A, and this angle here, it's not all of C, I'm going to call it T for top. These two angles actually must be congruent to each other because those lines are parallel. So I'm going to mention that here. And that must be true by the alternate interior angles of those purple lines. Okay, so now we get to use the bit about M and P being parallel and M and N being parallel, therefore P and N must be parallel. So we'll mention that part. We did that in the last video, on the transitivity of parallel lines. So if these bottom two lines are parallel to each other, I'm actually going to have this angle up here and this angle by alternate interior angles. So we'll mention this one, B for, I've already used B. We'll do L for lower. And that must also be true by alternate interior angles for these two, the transversals, this black one here. Okay, so this angle here, C, it's actually cut into these two parts, so officially I'm going to need to make mention that C is equal to T plus L. So we'll do that next. And this was the angle addition postulate. Remember that if this whole thing is split into this portion and this portion, where there's no overlap and no gaps, then the sum of those portions is equal to the whole thing. So T plus L is equal to C. And now we know that T is A and L is B, so we can make substitutions. Running out of some space here. Okay, so we got T replaced with A, and the L here replaced with the B, and this essentially gets us to where we need to be at the end. Replacing with those letters, we get that A plus B is equal to C. Alright, so this one, kind of interesting. We use that transitivity of parallel lines and the angle addition postulate, and two applications of alternate interior angles. Okay, good stuff. Character and scholarship for life.